Hi everyone, thank you for joining this policy workshop in the SCORES project. So today's morning is dedicated to a few presentations from the project, one from TNO, coordinator of the project, one from RINA on the current European legislative framework, and one from myself from EDF on the technology we are developing and demonstrating in the project. And then we have also external speakers, thanks to them. Mr. Andrew Michesh, sorry, from the RHC platform, and also from ADEN, Mr. Nuno Batista. And also Régine Bellhomme from EDF also. The general rules for this morning workshop. So the workshop is recorded and will be posted later on the SCORES YouTube channel. There is a six speech that will be shown this morning. Roughly 15 minutes per topic, and at the end of each topic, of each speech, there will be a 5-minute Q&A session. So questions are welcome also in the chat. And Pavel Bodis from TNO will chair this session, this workshop meeting, in order to ask the question also during this Q&A session. So thank all of you, and I propose to start now. Pavel, maybe I leave the floor to you to introduce speakers. Introduce first TNO and with a general presentation of the SCORES project.
Yeah. Thank you very much, Gilles. Indeed, my name is Pavel Bodis, and I'm working at TNO, and I'm a technical coordinator for SCORES project, and I will be happy to guide you through today's policy workshop of the SCORES project. The first presentation today will be given by Dr. Evan Healing from TNO, who is the coordinator of the SCORES project, as well as very experienced project manager with over 20 years of experience in EU and national projects in the Netherlands via his job at TNO. Erwin, please go ahead and give us your view on the SCORES project.
Okay, I will share my screen. Please tell me if you see it.
Yep, everything is good.
Okay. So good morning, everyone. I'll give you a short introduction on the SCORES project. So what is going on, what it's all about? It's all about the energy transition and the intermittency it will give us. You can put PV panels on your roof, but at times when you want to cook, there's no sun. And at times there is sun, you don't have to cook. So there's intermittency and a mismatch between production of sustainable energy and the demand of it. Furthermore, for example, in the Netherlands, our local grids are really at its limits. You can't just put an additional wind park in some regions in the Netherlands. It's the same in some other EU countries, but this means that we have very limited possibility for installation of large-scale renewables like PV and wind parks. And even sometimes the PV panels on the roof of some domestic buildings cannot deliver back to the grid. This means that a lot of energy is wasted. And a solution for that is to use storage. So the SCORES project is about self-consumption of renewable energy by hybrid storage systems. It aims to combine and optimize multi-energy generation, so that means electricity and heat, storage and consumption of local renewable energy and grid supply. Via the development of these compact storage technologies, we integrate everything in a building using a building energy management system, and that would lead to a reliable operation over the year with intermittent energy supply and demand. And also, of course, we are looking at the cost because we want to have a positive business case. The SCORES project has 12 partners. It started in 2017 and extended to April this month. So this is the last month of the project with a budget of about 6 million euros. So this is the overall concept. In the middle, we have the SCORS hybrid system. We have electricity storage. It can convert electricity to heat, and we also have heat storage in the project. On the input side, we have surplus renewable energy from the grid, if it's available, locally produced electricity, and also we have district heating. We could have grid feeding in from industrial waste heat, for example. And on the demand side, we have apartment building, houses with space heating, domestic hot water requirements, electricity use, and we can also refeed our PV back into the grid if possible. So how can we optimize this whole system such that no energy is wasted anymore? That's the question. So the consortium consists of companies on the top, and they're busy with. They have been working on new technologies for electrical and thermal storage and energy conversion. We have consultancy firms to evaluate all the results. We have local community for the demo sites, and we have the research partners on the bottom together with the communication and dissemination partner in the project. The objectives of the project are to demonstrate in the field of integration, optimization, operation, new compact energy storage technologies. And this connects the urban environment, the local environment with the regional environment. The technologies that we develop are, we develop 5 main technologies. I'll come back to that later. I'll show you some pictures of it. And then we integrate everything using a building energy management system, and we assess the economic potential of the total system. So these are the demonstration cases. We have 2 cases, one demo in Austria and one demo in France. The Austria case has a connection to the heat grid, and the France demo does not have a connection to the heat grid because in France, mostly cooking and heating is done with electricity still. So the Agen France is a new constructed apartment building with 115 small apartments. And in Gleisdorf in Austria, we use an already existing residential building block connected to both electricity and local heating networks. So 2 regions in Europe with different climate conditions. Now I will quickly go to the technologies that I earlier mentioned, just give you some pictures, some ideas. What we developed is heating with air heat pumps and PCM storage. So here you see a picture of it in a room. You can install this in the living room or in a big bedroom. What it does, it can heat your room, but it can also store temporarily heat in case, for example, at night when you use the heat, and in the daytime we can charge it using PV panels. We also installed and demonstrated heat and water-to-water heat pumps. So that's a solution for production of domestic hot water. We're using low temperature flexible solar collector on the roofs, and then you can use a heat pump. So from water to up the temperature for use for example, showering or heating. We also use photovoltaic solar collectors, but hybrid, so both PV and heat. And this hybrid system improves the efficiency of the photovoltaic panels through heat transfer because it lowers the temperature of the PV. So you get more out of your PV, and also you get heat delivered at the same time. So this is the layout of the demo site in Agen. We have there 129 PVT panels, 7 cubic meter of water buffers, which is also heat storage, and 3 heat pumps. So on these roofs, we put PVT panels, and that looks like this. Then we also have developed chemical looping storage, which we call redox heat. And redox heat works by oxidizing or reducing a metal. And in this way, you can store energy for a very long time, even for seasonal storage. And this technology is developed up till a TRL level that we still use in the lab. And this was not used actually in the actual demo sites at the moment. So this needs to be developed further. Then we have electrical storage using second life batteries. And this uses refurbished battery units from electrical buses in this instance for this demo. But you could use any second life battery. However, there are some drawbacks to it. and I will come to that later a bit. Then finally, we connect everything together using a BEMS, a building energy management system, that controls the equipment towards an optimal point based on predictions from the weather, also the available energy or the energy cost. So it can take from the grid, deliver to the grid, use the PV electricity for direct use, or it can store it, and you can have a smart grid fancy algorithm to optimize everything towards optimal use, self-consumption, or economic benefits. So my last slide, what are the barriers for implementation of this hybrid energy system? Well, first, it's about standardization of technologies. What we learned is that you can have a lot of different equipment and try to connect it together, but it doesn't always work as planned. Even if you design it properly, you have to have standardization of interfaces and, for example, for the BEMS, protocols and algorithms, because you cannot just connect everything to everything as it is. It needs a lot of development and planning. Also, this holds for the batteries, actually. We learned from the second life batteries that these battery cells are proprietary to the brands that you use. There are, for example, control systems in batteries that we cannot open up. They're not open source, so we sometimes don't know how to connect them properly, and this is very important in the future. We would not now suggest to use second life batteries, but just use first life new batteries for electricity storage. But when we started in 2017, this was we had a different opinion. So standardization of technologies is important. Grid aspects are important for heat and electrical grids. It's about capacity of the grid. If you want to have flexibility of the grid and feedback options, this should be possible somehow. It's not possible everywhere. So there comes the role of the grid operators, smart grids. If you want to optimize in an urban community, you need to also have smart grids providing data to a central point and distributing the energy in an optimal way. So this is also about local community building. You see this more and more, where we have shared energy generation. You have a shared investment in PV panels. You can have shared distribution and storage of energy locally, for example, in an apartment building. But still you have to have contracts in place and the right agreements with each other. And also about aggregation services, providing flexibility to the grid, delivering energy back to the grid as a local community, for example. Then we have the safety and environmental aspects. These technologies bring new technologies into the domestic environment. So you can think of new materials, lithium ion for batteries, hydrogen for energy storage, for the CLC system, for example, PCM materials that have never been used before in the domestic environment. And you need to have this well thought out. And also you need their permitting and safety guarantees, of course, before you can implement them. And then last but not least, the hybrid energy system cost. You need still a lot of investment for further commercialization of these technologies. So this should be paid by someone, and maybe there can be some subsidy scheme, for example, to make this, to accelerate these developments. And you also have to talk about the variable costs, like the tariffs, the taxes, the contracts between the local communities and the grid operators. So this all should be sorted out before we have this smart grid hybrid energy system well in place and we could benefit from it. But this is all touching into the policy side and the regulation side. So from my side, I would leave it here. Thank you very much. And I'll give you back the floor, Pavel.
Thank you, Erwin. I was just going to tell you 1 minute to go. So perfect timing. Thank you very much for that. And thanks for the good and clear presentation of the goals and results of the SCORS project. I will leave now the floor open for questions from the participants or from the audience. So please go ahead. I have not seen any questions yet in the chat. So please feel free to also post your questions in the chats. Any questions from the audience so far?
Okay, you can always drop me a line and ask questions under the YouTube video.
Indeed. So far, thank you very much, Erwin. And the next presentation we move on will be given by Francesco Ornesano from RINA. He is, in fact, an head of the Green Building and Energy Efficiency Services in RINA Prime, which is a part of the large RINA group, and it's mostly focused on in the Italian market for real estate consultancy business. He's also participating in the Circular Economy Committee of Association representing the real estate companies, as well as in the ENEA Coffee Industrial Energy Audit Roundtable. Francesco, please go ahead and tell us a little bit more about your view on the policy and legislation with respect to energy systems. The floor is yours.
Thank you very much, Pavel. Yeah, I try to maintain the right time. The chronometer. Okay. My presentation deals with the legislative framework about in Europe that we have in Europe that involve the buildings and the framework where the hybrid system like SCORES system the system that we have developed in the SCORE project will be installed. First of all, the main pillar of the European policy framework are the 8th Environmental Action Programme and the Energy and Climate Regulations. From this pillar started some operative directives that are focused on decarbonization. We focus more mostly about the EPBD directive, the Energy Performance Building Directive, that is developed during the 2010 and was amended in 2018. But there is another version that will be soon updated. There is also the Renewable Energy Directive, because SCORE include also the renewable source, so the legislation about the renewable source are quite important. And another important directive is the Energy Efficiency Directive as well, that include only partially the buildings, but is main focused on the saving on the energy final use. There is another directive, very important, because talk about the interaction between the building system and the external system. The external system regarding the electricity market and the electricity public system. The ambitious objective of all of this regulation is to transform the Europe in the first carbon neutral continent. So starting from the goals and after that we try to see which tools the European legislative framework have developed in order to reach these goals. The goals are the energy security, and as we see now, it's quite strategic and important for the Europe to consume less energy is possible, because the fossil fuel production in Europe are less than the fossil fuel use. So we depend of external region of the world. Another important point is the energy market. The integration of the energy markets around all around Europe, and the integration between the member states. The improvement of energy efficiency, the decarbonization is became one of the most important driver into the last legislative directive. And research, innovation, and competitiveness are increasing in Europe. We work a lot also outside of Europe, and we see that in Europe we have particular attention. So our services, our products are focused on the energy efficiency, and so this and the saving of the energy. So it's quite important goal for the Europe, also for the export outside. So we will develop these goals with renewable energy, with the energy audit and the labeling of with the energy performance certificate, with a new market design, and with the fight against the energy poverty. The technical goals are to reach the carbon neutrality within 2015, with a lowered global warming increase by 1.5 Celsius degrees above pre-industrial level, and a midterm goal are to reach greenhouse gas emission, a reduction of greenhouse gas emission by at least 55% compared with 1990 by 2030. So this is the three main directive. I want to focus first of all on a concept and what happened from the directive of 2010 and the recast that we foreseen in 2022. We start to talk about near zero. We have talked right now until now about near zero energy building. So we reduce the consumption, and we use half part of energy by renewable source. But we will transit to another concept. The new directive talk about zero emission buildings. So we start to define this building with a production or a CO2 production right now should be arrived to a very, very low level of CO2 production. So the focus is not on the energy, but the focus is crossed arrive on the emission, and how which is the main tools that we can use to reach this emission is defined into the definition into the recast proposal. They talk about the production with renewable source generated on site, like the SCORES project propose, and the renewable energy community. So it's become crucial to store the energy and try to produce as much as possible the energy on site, the renewable energy on site. I show you the main pillar of APD directive, and in red I show you which is the news that we foresee about the recast that will be arrive soon. So there is methodology of calculation, minimum requirement. We see all of the aspects into the next slide. There is also some news about the minimum requirements, so I want to show you also this aspect. About the minimum requirement of energy performance of buildings, we starting to talk from 2027 of zero emission building. All new buildings occupied or owned by public authorities from 2027 will become net zero buildings. And from 2030, all other new buildings will become zero emission buildings. Another important point is the life cycle global warming potential is being included into the energy performance certificate. As I already seen, the global warming potential, so the CO2 production is became one of the most important indicator in the future of building environmental evaluation. Other aspects that is very controversial because it's a very strong that could be have a very strong impact on the life of the people and on all the real estate world is a standard for the an energy performance standard for the existing buildings. Until now, we have all of the European legislation that talked about only the improvement of the energy performance on the new buildings or the refurbished buildings, or in the building when you change the boiler or the generator. In this case, we're starting to talk about existing building, and is required from 2027 to 2036, 33, that also the existing building shifts the worst energy, inefficient energy building, shift the energy performance at least to class F and or class E, to be should shift their class. So will be required intervention also for existing building. I don't know how the member state interpreted this. I don't know also if this aspect that is very controversial, as I've seen, said, will be included into the final version of recast, but the document shared by European by the Europe right now include also this aspect. Another interesting news is the inclusion of this new document that is a renovation password, quite similar to the energy audit, because include into the building analysis also a focus on the renovation steps in order to transform a building in a zero emission building by 2050. And it should be include especially the expected benefit in terms of energy saving, saving in the bills, and operational greenhouse emission reduction, but also in health and comfort into the building, and contain also information about financial and technical support to achieve this objective. Other aspect included into the PBD is the inclusion into the new buildings of electromobility infrastructure, and the inclusion of self-regulating device in order to regulate the indoor temperature, and the obligation for all not residential building of a building automation and control system. It's very important also for SCORs, because in order to manage all the energy come from the different renewable source, a building automation system is crucial, is fundamental. Is we cannot avoid to have this system, and it became an obligation for all not residential buildings as well. The smart readiness.
About 1 minute to go.
Oh, okay. I'm close, with the smart readiness indicators, and it's a new new tools that give you show you which is the smartness of the building. So if a building and BMS reach to adopt the operational need of the occupant, optimize the energy performance, and allow the energy flexibility. I can conclude my presentation with this. I'm more focused on the aspect, but in the presentation you follow also some indication about Renewable Energy Directive, Energy Efficiency Directive, and the internal market for electricity as well. Thank you. If there is some question, I'm available.
Thank you very much, Francesco. Indeed, are there any questions from the audience or from the co-presenters of today? If not for the moment, I would like to thank you, Francesco, again for your quite complete presentation about the legislation aspects of the and regulation aspects of the storage technologies in general in built environment. And I would like to invite now our following speaker, Nuno Baptista from Adene, to present us his view on these topics. So let me first briefly introduce Nuno. He is an architect and coordinator of the Building Energy Performance Certification Scheme in Adene, which is a Portuguese energy agency. He has joined the building department in Adene in 2010 and working on the quality assessment and also in a managing platform for issuing energy certificates there. He will present us today his view on this topic of legislation and in Portugal. Please go ahead.
Hello, good morning. Just trying to put the PowerPoint. Yeah, I think probably not the best. Just change the way I present the. Yeah, it's best this way. So I'm basically doing a wrap up, or try to have an overview regarding the energy efficiency and policies that currently are implemented in Portugal, as well as a brief overview of the energy performance certificates system in Portugal. The overview that I would like to present is basically how different regulations came to force throughout the years in Portugal. So until 1990, we didn't have any regulation regarding buildings, and so 1990 was the date for the first. Sorry. 1990 was the date of the first regulation for residential buildings, and afterwards in 98 for non-residential buildings. We had on top the different directives, different versions of the Buildings Performance Directive, and on the bottom part of the slide, when was this directive transposed to national regulation? So we had first transposition in 2006, where we had regulation for residential buildings, non-residential buildings, and also for the energy performance certificates. Later on, for the recast of 2010, we had an updated regulation in 2013, where we had a single document, a single regulation that compile all different requirements for residential, non-residential, as well as the certification system. And quite recently, due to the recast of 2018, we had this new decree law from the end of 2020 that came to force in 2021. So we have roughly 7-8 months of this new regulation. And the idea behind this improvement or stepped improvement in terms of the regulation is to allow buildings to, on one hand, to reduce and to have strategies to reduce their needs, the needs of consuming energy and reduce the consumption of energy, and through something that has been tackled from 2006, a share of renewable energy that must be included in this building. So basically reducing the energy consumption and improving the amount of renewable energy sources, we tend throughout the years to achieve NZEB standards, and hopefully from the upcoming directive, zero emission buildings throughout the years. So, and these latest regulation also include electromobility and other aspects for allowing us to have more intelligent and more interconnected buildings throughout the years. The requirements that that buildings must comply, we have requirements for the building envelope, windows, for technical building systems, as well as energy performance and thermal comfort requirements. But building owners must have some additional obligations regarding this same building. So they need to have installation and maintenance obligation, reports, technical system documents. Where applicable, they need to have periodic audits, building automation and control systems, electromobility, inspections, and a control of the indoor air quality. So a lot of obligations that building owners must comply to have this kind of buildings and to have them in the normal running stage. And the third part of the regulation states focused on the energy performance certificate scheme as a whole. Apart for this building regulation, Portugal, as well as other member states, but in this case, Portugal had to put in practice this long-term renovation strategy, focused specifically on building energy building renovation. And the idea is to have by 2050, a building stock that is decarbonized, very efficient in terms of energy use, and upgraded to these NZEB standards. All the policies and actions that support this strategy were designed to foster deep renovation of these buildings, and the idea is to try to diminish and to overcome what we have as less efficient buildings, and again focus also on reducing energy poverty. The long-term renovation strategy sets on 3 goals. When the first one trying to focus on the improvement of the living conditions for building occupants or tenants, being this one of the major issues that were identified also on studies regarding energy poverty. It's also an opportunity for an economic growth and a mean to achieve the energy and environmental goals that Portugal has agreed upon. On top of that, and due to this COVID scenario, it's also a possibility for a revival of the economy after this some years of this pandemic state that we still live on. The 4 packages of measures are stated on this roadmap. There's one focusing on energy poverty, improvement of the energy efficiency of buildings, local decarbonization, and later on an additional comfort improvement of buildings. So On blue, you have residential buildings. On black, you have non-residential buildings, and this is the expectation to have these building stocks renovated by 2030, 2040, and up to 2050, and a set of measurements and actions are put in practice in order to boost and to put all the effort that is needed, because 2030 is just around the corner, and some quite significant share of residential stock should be renovated by 2030. The actions, the set of actions that are defined on this long-term renovation strategy go for building renovation, smart buildings, in these 7 axes of actions, divided in 13 typologies, 28 policy, giving a grand total of 146 actions that all combined should break the barriers and boost not only the economy but the owners in order to deep renovate their buildings. A tool that links directly to this long-term renovation strategy, in this case, is the Portuguese Resilience and Recuperation Plan, funding from the European Commission, but with a total of over 600 million euros just for improvement of the energy efficiency of buildings, 300 million for residential buildings, 70 million for non-residential buildings, and 240 million for governmental buildings. Overview of the building stock in Portugal. We have 3.5 million buildings, which comprise 6 million dwellings, and the vast majority of these buildings have 1 or 2 dwellings, and more reduced share of 15% for buildings with over 3 dwellings. And according to National Institute of Statistics, we have still a quite significant share of buildings that already need repairing. So the idea is try to combine the need for repairing with these strategies and try to boost the renovation and the improvement of these buildings. Like I said, until 1919 there was no regulation that applies to buildings, and we see that almost in this case almost 4 million out of those 6 million dwellings were built before 1990. So we have a significant amount of buildings, or in this case dwellings, that don't have any requirement or any concern when they were built regarding comfort or pathologies, or in this case of trying to improve the quality of living for those tenants. Throughout the years, we had different regulation that applies. However, the number of these of the buildings that were built within this scope is it's much more reduced. So no matter how demanding these last 2 regulations were, they do tackle a very reduced amount of the building stock. The energy performance certificates scheme is we consider it as a very robust system. We have it for 14 years now, more than 2 million EPCs that were already registered, more than 3.5 million recommendations or improvement recommendations proposed by these over 2,200 experts scattered throughout the country. The investment of these recommendations are estimated at over 10,000. Well, little mistake on the numbers, but 10,000 million euros of investment and 1.3 million euros years expected savings if these measurements were applied to the buildings. quick overview of the last years. A number relatively constant of almost 2,000 EPCs issued per year, mostly residential, 90% residential. More than 80% of these EPCs stated for already built buildings, and only a more reduced share of EPCs that were issued in the design stage, where a high level of energy performance must be achieved. And most of the EPCs are issued for existing buildings, and this small share for new buildings or for major renovations. So major renovations are still a more reduced share of the EPCs that are issued in Portugal.
2 minutes to go.
Okay. This is the percentage of energy labels that we have. We have an inefficient building stock, almost 2/3 of them on the lower grades. And this blue line here shows the amount of renewable energy sources that we have for each label. So big percentage of renewable energy sources on these high efficient buildings, then of course 10 to 0, let's say, on the worst classes. Residential, the most significant share for consumption is for heating, followed by domestic hot water, while in non-residential buildings we have lighting, followed by cooling as the major aspects or the major consumptions of these buildings. How can they be improved? They can be improved mostly on building envelope, heating, domestic hot water, windows. This is the type of recommendation that's been forecast by the qualified experts. The average investments ranges from 6,600 euros per apartment with an expected savings of 900 euros per year, up to 77,000 euros with 14,000 euros savings for large non-residential buildings. And this is a small non-residential building here in the middle. And how can we help buildings to be renovated? This recuperation and resilience plan open a call for the more sustainable buildings, in this case residential. We had already over 82,000 applications in less than a year, over 22,000 less than a year, no, less than 6 months of this call. Over 22,000 applications were already paid, and they focused mostly on PV installation, 40% of them for PV installation, 35% for window replacement, and 25% for heat pumps. So a huge amount of equipment, high efficient equipment, and PV installation being installed on these buildings. We have a leverage of 1.5, so 35 million euros paid, which represents over 56 million euros of investment, 44% of primary energy reduction, being the threshold of 30%. So good example, good results here, and 44 megawatt hour installed in terms of all these equipments. And my last slide is saying that the slide before was for residential. For non-residential, what we have, 2,000 maximum of 200,000 euros per application for non-residential buildings, and up for 5 million euros for public buildings. And they have the possibility to install PV, heat pumps, solar thermal collectors, biomass equipments, but also energy management systems are also eligible for this application. But still, batteries and storage is something that is not eligible so far. So the idea was for me to show what type of policies we have implemented, what type of mechanism helping funding or schemes that allow for the buildings to be renovated, and what are the expected results of these funding schemes. So this was my last slide. Thank you for the opportunity. Feel free for some questions.
Thank you very much for your information and for your presentation. I am looking at the chat. Gilles, you have a question with regards to the policy. Could you please
I can comment maybe.
raise that?
And I know that, so we saw in the two previous talk that there are ambitious objectives in order to increase the energy performance of building. In practice, is there some forced measure, I mean in Portugal, to force the landlords or the owner of such building to implement strong renovation in their building, except from the subvention scheme, I mean, but I know some of the measures in France, and in particular this measure that I mentioned in the chat, where the owner of such building, of such dwelling, won't be able to rent such dwelling after 2023 and 2028, depending on the energy performances. But is there similar measure in Portugal?
Yes, we have an obligation to have an improved building, and so the building owner must have some kind of intervention or renovation on that building. However, only focused on non-residential buildings. So that we don't have any means so far. The draft of the EPPD most likely of the future EPPD will most likely have an impact for residential buildings, and Portugal will probably would have to implement it as well. However, what we currently have is just for non-residential buildings, mostly large non-residential buildings, over 1,000 square meters, that have either worse performing labels or higher energy consumptions. Either by one side or the other, they are obliged to have an improvement plan of their energy performance, and the idea is for them to have either an increase of the energy label or a reduce of the consumption, and they have up to 8 years to implement that plan. So they define a set of measurements focusing on those goals that they need to achieve: improvement of class plus a reduction of energy savings. And after those 8 years, if the building still is a large consumer building, let's say, with large consumption, better said, they would have to undergo a second plan and so on and so forth until they are, let's say, exempt because they already achieved a higher set of a higher standard or a lower consumption. Basically, we have that just for non-residential buildings.
Yeah.
I have also one more question, if I may. You mentioned that the legislation or the rules have changed a little bit in Portugal in recent time.
Yes.
Considering the speed with which the energy transition is taking place in Europe now, for all the maybe wrong reasons, but all the reasons, how do you see the dynamic of change of legislation in Portugal?
Well, what we have so far is an EPPD draft being almost reaching to an end, let's say, and an expected publication. And Portugal is already considering that it will have to speed up the process and reducing the time from the Commission publishing the directive and the year or the date that the member state would put in practice. We've seen throughout the years that those the time differences tend to be reduced throughout the years. So probably not so good example, but we had the recast in 2018 and we had the publishing in 2020. And if we tend for this reduction, hopefully we'd have, well, we would like to have quite briefly after the publication of the directive, because there are some changes that we would like also to foreseen on the methodology of calculation. So would be a good opportunity to make more significant changes in terms of methodology and try to align them with well, some other aspects and some other requirements that the new directive might bring to discussion. So hopefully it would be in a near future after the publication of the commission.
Yeah, clear.
Our goal is
So
to have 1 year something.
Yeah, so on the behalf of us, of the scores partners, but also I think for okay, if I just say for all the households and all the people, it would be good to implement the more clear difference between the locally stored energy and locally generated energy sources with respect to the grid itself.
Yes.
That would be for us quite important, considering that the grid is getting full and not everything can be solved by that.
Yeah, for sure.
And
we are starting here also with the renewable energy communities. So we need to know how to put them, how to consider them in terms of calculation, in terms of performance. So there are some aspects that are all running side by side, and somehow we need to streamline them into a into a more well, coherent approach for all these small parts that are being
big challenge ahead of us for all of these things, and I think not only in Portugal but in all the countries, considering the challenges we face. Sure. Again, thank you very much for your clear and very comprehensive presentation. And I'd like to, as a follow-up, ask Gilles Plessis to join us with his presentation on the cost and profitability of score system in different contexts. A short intro for Gilles. Gilles has joined EDF R&D team in 2010 to work on the modeling simulations for building envelope and the energy systems. And since 2021, he leads the project on the PV self-consumptions within the EDF group and coordinate various collaborative research projects in that domain. So Gilles, the floor is yours.
Thanks, Pavel, for this introduction. So after these two previous talk, more focused on standardization, regulation policy, I will try to cover in my talk learnings from the SCORES project in terms of benefit of SCORES system, benefit of SCORES technology, in terms of technical benefit, but also economical aspect. So, as mentioned at the beginning of the workshop by Erwin from TNO, one important aspect in the SCORES project is that we wanted to demonstrate the application of the SCORES technology on two real cases, one in France and one in Austria. So the first one in Austria was focusing on residential and offices building. In this case, we were implementing a score system, various kind of score system with renewable energy, local renewable energy and storage system. And the specificity also of this demo case is that it was connected to the grid, electric grid, of course, but also to a district heating grid. So that was the demo case which was more representative for Northern Europe case, and in the demo B case in France, we are choosing a residential building, also implementing installating score system in it, so different kind of score system compared to the previous one, but system also for having local renewable energy resources and storage capability. And in this case, more representative for a Southern European country, let's say, it was only connected to the electric grid. Few words on this demonstration in France, focusing on demo B. in this case. So the building was a residential collective building for retired people, so a residence for retired people, composed of a bit more than 100 small apartments with a total collective surface area of more than 6,000 square meters. It's, as we mentioned, also a quite recent building, so it's compliant with thermal regulation 2012 in France. That means that the energy consumption, especially the share of space heating, is not so important compared to previous building, due to the fact that the insulation level is quite efficient. It's quite important. So we are located in south of France, so we benefit from a warm oceanic climate, roughly 2,000 heating degree days for this location in Agen, compared to an average of 2,800 heating degree days for Europe. No district heating connection, and as a large share of building stock of building in France, the system, the space heating and domestic hot water is mainly covered by electrical system, which make also the system quite thermosensitivity, and so induce some constraint on the electrical grid. So challenges for this kind of building, or for cost project, also to improve energy efficiency. So some part of these challenges are a bit aside from the SCORS project, especially thermal insulation. It was not, our building envelope performances was not at all covered in the SCORS project, but nevertheless, we were trying to see how, for instance, heat pump can bring energy efficiency compared to traditional electric heater, and that's also part of the SCORS project. Increasing also share of renewable energy, local renewable energy, and to deal with intermittency of this kind of energy, we wanted to assess how we can increase the flexibility by introducing capacity, storage capacity, either thermal capacity or electrical capacity, storage capacity, sorry. Aside from the demo, the two demo that I was talking about, so that they were more focused on proving or assessing or validating the TRL progress for this for the SCORS system, and being able to assess the real life performance. But the drawbacks a bit of this demonstration is that we were able to operate them only during few months, because it takes time also to install them, to make the whole component communicate between them. And so we had done only not whole year long operation, and we wanted also, aside from that, to assess what could be the benefits of the SCORS system on a yearly basis. And for that, we were relying on simulation for carrying out sensitivity and prospective analysis. So one of the first steps was having this calibration phase between the demo, actual monitored data on the demo site, and the model we were developing. And that was quite important to be able to draw robust conclusion afterwards. We were choosing also, we had chosen design of experiments in order to make the sensitivity analysis on different kind of configuration, with and without heat pump, installing PV and installing PV and PVT, and also varying the storage capacity. So you will see that a bit later. One other aspect of the design of experiments was also the electricity tariff, so taking into account several time series and prospective scenario for 2018, 2030, and 2050, and both flat tariff and day tariff. Along with this electricity tariff, we are testing and developing two control strategy for the BEMS, consumption and economic optimization. So you see on the right-hand side table describing the naming convention I will use in my presentation. So we had a reference case with only electric heaters and boiler. So the same building as the demo, but with a specific system. SFSB with no PV, where we want to install only heat pump for both space heating and domestic hot water, and then adding the PV and PVT, and afterwards making this battery size varying. Just for the reference case, looking at the energy breakdown, monthly energy breakdown, what we can see that in the end, we have of course a large share of energy needed for specific electricity usage, but still we have also not so minor share, I would say, for space heating and domestic hot water. You can see space heating is represented in orange and occur during the winter months, and domestic hot water is in blue here. 2 times higher energy consumption in winter compared to the summer. Compared to the summer period, that's the thermosensitivity of the building, and roughly at the end, the key performance indicators are a bit more than 100 kilowatt per square meter and per year. And in terms of CO2 emission, considering the French energy mix, French carbon content of electricity, we end up to building with quite low emission, around 7 kilo of CO2 per square meter per year for this usage. Adding both the heat pump for the domestic hot water and for the space heating and the PV and PVT, we've been able to identify the current considerably reduced needs for electricity from the grid. So basically, the part of PV here is providing a large share of domestic electricity, so specific electricity use, and also contributing to the water-to-water heat pump needed for domestic hot water. What can be seen also on this Sankey graph is that the distribution losses are quite important for the domestic hot water. So that's a bit aside from the SCORS project, but that should be taken into account when we talk about overall energy consumption. And integrating air-to-air heat pump reduce also the energy consumption due to space heating, because a large share of energy is provided by ambient air. Solar thermal PVT system from Heliopac is also providing a large share of domestic hot water, roughly 70% of domestic hot water need. Nevertheless, we still have, with this reference case without battery, we have a large PV exported to the grid, PV surplus around 55 megawatts hour per year. Making the battery size varying, so having this 6 use cases from 50 kilowatt hours to 300 kilowatt hours of battery size, keeping aside the PCM, so phase changing material capacity, and also the CLC, chemical low combustion storage. We've been identifying that this kind of or introducing the battery will actually reduce marginally the needs for electricity from the grid. So moving from this case, SFS0 to SFS6, for instance, when we introduce a large capacity battery. So from reducing the needs from the grid from 56, something like this, percent to 60%. So the main benefit is actually bring by PV and heat pump and then PV, and therefore battery afterwards contribute, but to a less extent to this reduction. On the other side, PV surplus is really reduced by the battery, and that's also a good point of this kind of system. Looking a bit on the other side, let's say self-consumption and self-production. So as I said, PV, surplus PV is much more reduced. So with a large battery, we end up with 90% of the PV production, which is actually consumed locally, used locally, sorry, compared to roughly 70 for the SFSB case. But in terms of covering the energy needs, local energy needs, introducing the battery, we are able to increase the self-production rate from 30% roughly to 38%.
2 minutes to go.
Okay. Nevertheless, looking at the duration curve, we see that the peak power is much more reduced, and also we have some interesting events with the grid, and we are able to reduce, thanks to PV and battery, large share of connection to the grid, exchange to the grid at low power needs. Okay, so on the right hand side, you have the breakdown, energy flows, and monthly breakdown with the smallest battery simulated, close to the one in the demo site. And you see for both strategy, economic optimization and self-consumption optimization. In this case, self-consumption optimization, battery is only charged with PV and it's occurring only during the summer period. For the economic optimization, it's occurring all year long thanks to the BEMS play, charge the battery with the grid or with the PV. And that's what we can see also here for a typical winter week, where the PV battery is charged from the grid when we have low tariff on the grid. In terms of OPEX, so electricity bills and CO2 emissions. So you have the bills in the bar graph and the CO2 emission in the scatter plot, let's say the point. So CO2 emission can be reduced also with the battery. The main part is also coming from the PV and heat pump. And the difference between self-consumption strategy and economical strategy is not so much for the case we are simulating here. So the day rate tariff might be a bit away from what we can see nowadays, but that's the assumption we are taking during this project, and indeed the CO2 emission still is reduced to nearly 2.5, 2.6 kilogram of CO2 per square meter in per year. So key takeaway from this presentation and the work we've been doing. Share of renewable energy might be significantly increased in building with core-like technology. So heat pump, PCM and heat pump, PVT and water storage and so on. PV sizing and battery, the couple between PV and the battery sizing is really key. The larger the better, but also it should be adapted to the need. In this case, we are really limited by the surface on the roof for the simulation. That's also things to remember when talking about this result. And electric battery are nowadays, so it's not directly shown in this presentation, but introducing the capex make the system really also expensive when you want to integrate a large electric battery. Nevertheless, several things change since the scores beginning, especially a strong push for self-consumption scheme on PV and not so much direct injection anymore. Hydrogen market and electricity mobility also are taking off and that's also brings some additional capacity, storage capacity with high power rating that could be leveraged for integrating more and more renewable energy resources or dealing with intermittency. We have also the development of stationary batteries, so you can see that on the right hand side. And then one of the key conclusions is also that some other value need to be found to make this kind of system profitable, and that could go through flexibility mechanism, flexibility market, for instance, to provide this kind of additional value. Yes, that's all for my parts.
Thank you, Gilles, for a very clear presentation about the scores results and their impacts on the technologies and how the energy flows, and also some words about the challenges on the economics and how to make these kinds of systems profitable. Are there any questions at the moment? I don't see any questions in the chat. I also don't see any hands raised. So my proposal would be to go ahead to the follow-up presentations of EDF, which addresses, I think, one of the main questions that Gilles has raised. Where do we see economic value? And how is the SCORES project linked to the magnitude projects, another Horizon Europe, Horizon 2020 project, where providing flexibility to the European electricity grid systems has been investigated. I would like to ask Regine Bellon to present us with her view on the situation. Regine is a senior engineer and project manager at the Department of Power Systems, Energy Markets in the Research and Development Division in EDF. Her main activities concern the analysis of existing and future market design and regulatory frameworks in energy systems, and the integration of distributed energy resources and multiple energy systems as such. She was also coordinator of the magnitude project that she's going to present, which has developed various business models and market analysis that we will see now in more detail. Regine, the floor is yours.
Thank you very much, Pavel. Okay, I start. So can you see my screen?
Yep, very nicely. Thank you.
Okay, thank you very much. So as was mentioned, I'm going to present some learnings from the magnitude project regarding the provision of flexibility to the electricity system. And so first, a few words about the magnitude project. So this is a Horizon 2020 European project, a research and innovation action. And we started in 2017 and we finished last year. And so the coordinator was EDF. In fact, I was the coordinator. And so in the magnitude project, we developed different optimization and coordination tools that I will speak about later, and also business and market mechanisms in order to provide flexibility to the European electricity system by multi-energy system. And I will explain what we mean by that. And so through enhanced synergies between electricity, gas, heating, and cooling systems. And so the objective was to support a cost-effective integration of renewables and enhance security of supply. Another objective of the project was to bring under common framework technical solutions, market design, and business models. And of course, to contribute to ongoing policy discussion in the energy field. This is the consortium of the project. So we were 16 partners from 9 countries and let's say with a complementary comprehensive expertise. So I'm not going to go to the description of all the partners. Just to tell that we had some utilities and local utilities, so multi-energy utilities, some solution providers for aggregation, for ICT, and for market simulation. We had some research institute and also universities. Okay, so this is the main concept of the magnitude project. So we, at the bottom here, we have the multi-energy system that are in fact the actual provider of flexibility. And so their flexibility is aggregated, so by an aggregation platform that collects their contribution and integrate it in an aggregation pool, which is composed with also other resources. And then the aggregation platform is proposing or submitting offers to the energy market and the service procurement mechanism. So in the project, we developed a whole chain of tools. First, for the simulation and optimization of multi-energy systems, so for the different technologies involved in the multi-energy system that we studied. We developed the different components and modules of the aggregation platforms to collect the flexibilities of the multi-energy system and submit offers to the market. So we developed also a market simulator in order to test some innovative market design for the day-ahead markets. And for the other markets, we had a market emulator that, let's say, play past sequences of markets. Yes. So the basic principle for the interaction between the aggregation platform and the multi-energy system, is represented here. So first, the aggregation platform sent a price forecast of the targeted market to the multi-energy system. The multi-energy system then makes its own optimization, taking these prices into account, and send back to the aggregator the flexibility that it can provide along with the cost or price to provide this flexibility. Then the aggregation platform builds the bids from the portfolio of from its portfolio of resources and submit them to the market. Then after the clearing of the market, so the market sends the results. So in case of bid acceptance, then the aggregation platform is going to dispatch the different resources in its portfolio, and in particular the multi-energy system. And then after the delivery and so on, so the aggregation platform receives the revenues from the market and distributes the revenues to the different resources that participated in the delivery. So the different markets and service procurement layers that we considered are described here on the right. So we looked at day-ahead and intraday energy market, balancing and frequency regulation services. So let's say reserve services for the TSO. So FCR, AFR, and MFR. So it's to say in the old terminology, primary, secondary, and tertiary frequency regulation. We also looked at congestion management for distribution and transmission system, and then capacity requirement mechanisms. So here are the multi-energy systems that we consider in the project. So we had 7 real-life case studies in 7 different countries. So we had, let's say, a district heating and cooling network in Sweden for Malar Energy. We had an integrated pulp and paper mill in Austria. We had, the district heating system of Milan in Italy. We had also a steel industry, combined cycle gas turbine, and large renewable plants in the UK. We have the wastewater treatment plant in Spain for Emiraza. And then we had also a low temperature district heating and cooling network in Paris, plus distributed units in substation. And then I will speak about Hofer, which is a special case and maybe more related to the SCORE project, where we had a low temperature district heating and a distributed unit at consumers, mainly heat pumps in collective buildings and electric boosters in family houses, in order to raise the temperature to produce hot water. And so for each of these case studies, so we studied the provision of the services that are mentioned here on the right, so I'm not going to detail. First in the existing configuration, and then in what we call an improved configuration, so implementing improved strategies that mainly consist in increasing storage or increasing the control and communication capacities and so on. Okay, now I'm going to speak about the result of the project. And the first thing is that regarding provision of flexibility, the multi-energy systems that we considered were mainly connected to distribution network. And that means that they meet the same issues as other distributed energy resources, like distributed generation, distributed storage, and in particular, the demand-side flexibility. So that's to say the flexibility of buildings. But they, of course, have some specificities since they involve several energy carriers, and that means that brings some opportunities, but also constraints. So we can get flexibility through fuel shift between the different energy carriers and also demand response on other networks than the electricity network. But on the other side, we have a balancing constraint between the different energy carrier. Multi-energy system also involve more stakeholders and more interaction, so that means a higher complexity. Provision, okay, now the result of the project, so we have seen that multi-energy system can indeed provide flexibility to support the integration of renewables, and they have potential to participate in energy markets, frequency ancillary service procurement, and congestion management. But this strongly depends on the technologies that are involved on the site, as well as the process behind this, or the core process, and the operation strategies. So the three main levers to provide flexibility are, as I have explained, fuel shifting, so demand management, both on electricity side, but also on the other energy carrier, and storage capabilities. So we have seen that multi-energy systems have large potential to provide flexibility, but there are limitations. In fact, the exploited flexibility is rather limited with respect to the available one. And so I'm going to look at some reasons here. And first, the technical capabilities of the technologies with respect to the requirements of the products that are traded on the market. For example, the ramping or the full activation time of the service, or the minimum duration of the product. So you have here a small figure illustrating that, with where we see that when the duration of the product increases, the flexibility that can be provided reduces more and more. So that means that there are some key parameters that really need to be known for the different technologies and monitored to be able to provide flexibility. Other limitations, we should keep in mind that for multi-energy system, and probably also for buildings, the priority is first to satisfy the needs of the main or core process. So in our case, it was to supply heat, cooling, to produce paper or steel, treat wastewater, and so on. So that means that flexibility is not the first priority, so we'll come after that. And that means also that the multi-energy system is optimized with respect to the core process, and provision of flexibility means deviation, so a change in operation plan, and so in a sort of disoptimization of the multi-energy system operation. And this can this can lead to increased operating cost, and in some cases also to increase greenhouse gas emissions. Not another, but a result from that is that multi-energy system will participate in the market only if they can get sufficient revenues to cover their extra costs. Regarding improvements, so the first one is, of course, the optimization of the operation of the different technologies by the energy management system on the site. But the second one that we consider is the introduction or increase of storage capacities, so heat, cooling, or gas. And what we have seen that it depends very much on the technologies, on the period of the year, and so on. And so that mean that this can increase flexibility by sometimes a few percent, but in some cases it can be multiplied by more than 5. This is illustrated here on the figure, where we can see without storage, so the flexibility appears in orange and orange and red, and with storage, in this case, it is increased very much. Integration of storage may also reduce operational cost, but a compromise has to be found because oversizing may reduce profitability. Another
2 minutes to go.
Okay, another important factor is aggregation of multi-energy system with other resources that allow multi-energy system to access markets that they cannot access alone. For instance, due to their limitation in technical capability. Also, aggregation provides a backup needed, so that's to say to have some resources in backup in case of failure of other resources that were planned to participate. It also helps in terms of trading complexity, as we will see later. So provision on market is very complex for small stakeholders. And of course, it allows to access some markets where the thresholds are too high, let's say, or the access threshold are too high for the individual multi-energy system. That means that this increase the flexibility that can be exploited, but this has a cost. Because of course the revenues has to be shared with the aggregator, and that means that this an additional price, an additional cost has to be added to the bids, and this can have a significant impact on profitability. Regarding market and regulatory perspective, so now we see on the energy market an ongoing harmonization. But also on the other types of market, but there are still some large diversity between countries for some mechanism. For instance, balancing and frequency services, capacity requirements, and congestion management. This is a very fast evolving field, so this is very complex for small stakeholders, and this also involves replicability issues of the tools. There are still some rules or requirements limiting the service provision by multi-energy system and other DERAs in some countries, like aggregation or some technologies are not allowed yet. And some issues, specific issues regarding some markets, like lack of liquidity or minimum bid size threshold, as I have explained. For frequency reserve, we see in some countries that the payment is only for energy activated by the TSO. That means that there is a risk for the profitability of the flexibility providers, because they may keep the reserve, but they may not be paid for that. And the symmetry of product. But as I have said, these are mainly the same issues for the other distributed energy resources, and a lot of them will be solved by the implementation of the clean energy package. We also see that another limiting factors is due to the increased cost due to network charge, taxes, some charges and contribution for the implementation of renewables. We have a need for compatibility, for an improved compatibility of incentive scheme for DSOs to procure flexibilities, but also for support scheme on some energy carriers with respect to flexibility provision. We need an improved coordination between network operator, not only on the electricity system, but between energy carriers, and of course a cross-sectoral approach for grid tariff, energy taxes, and so on. We also studied in the project innovative integrated multi-carrier day-ahead markets. So that's to say markets that are coupled, let's say, in terms of electricity, gas, and heat market. And indeed, we can see that this improved coordination and coupling between markets can increase the economic benefits, but at the price of higher computational time, and also in some cases organizational changes, and which mean that cost-benefit analysis are needed before any possible implementation. And then I will finish with the business models that we assessed in the project for the 7 case studies. And so we assumed sharing of 20%, 80%, so between the aggregator and multi-energy system operator. And so you see here, so on the graphic, so the B means the base case without the improvement strategy, and I with improvement strategy. And so you see that in some cases we cannot find, we could not find any business models, but in some cases indeed we had interesting business model. In particular for offer, here, which is where we had distributed units at consumers. We see that we can have a business model for heat pumps in collective buildings, heat pumps and heat storage, and we could not find a business model, a profitable business model for electric boosters in single houses. But of course, business model depends on regulatory framework, technological capabilities, revenue sharing between the aggregator and multi-energy system. And so this is just a list of the deliverable that you can find on our website. And so I thank you very much for your attention. Any question?
Thank you very much. Indeed, the good question is, are there any questions from the audience maybe to start with? I don't see any questions written down. I don't see hands raised, but I do have a few questions for you, Regine. You've shown us a very good overview of the progress in the project. And what I have a question about is related to actually the truly distributed energy storage systems that could provide stress flexibility. I see many examples you've shown are a rather large scale application, whether that's a paper mill or grid, heat grid systems. There was one example in Denmark, indeed, that you had some distributed systems. How do you see the perspectives of distributed electric car chargings, distributed heat storage systems in regular homes, not only heat grid systems? What are your perspectives on those concepts that are not addressed in the project, or don't seem to be?
In fact, in our project, we did not look at the electric vehicle charging and so on. But one thing, as you have seen in the results, to access the market, first they need to be aggregated. So that means that, in particular, because the threshold, the minimum bit threshold is probably too high for single houses. So this is one of the things. And of course, as you have seen, there are still some limitations, not only for multi-energy systems, though I have tried to present them in my presentation, but they apply also for the provision of flexibility of buildings or electric vehicles and so on. So regarding this limitation, one of the things is that, of course, aggregation can help for sure. Another point also is that due to the, well, presently, let's say, so the clean energy package, so the electrical directive and so on, and so the evolution are not fully implemented yet in the different countries, as you have seen. And some of the issues that I have presented are expected to be solved or at least improved for small consumers in the future. Also, I mentioned that there's a lack of incentive for the DSO to procure flexibility, but this should evolve, in particular with the new directives or the new. So normally they are now developing different means to procure flexibility at the local level, and in particular for local consumers. Now, there is an issue regarding the profitability, because when you install storage, but I think that you have seen this in scrolls, it has a cost. And the thing is that if you use this only to provide flexibility, I'm not sure that you will find the profitability. So that means that you really need to look at all the possibilities how to say, to use your storage and in order to find the profitability somewhere.
Yeah,
so I don't know if it does. Yeah.
That indeed is a very important aspect what you mentioned, and it does answer the question that I had. The value stacking is a key issue, and this is something that we see also from different projects and activities we have. That storage alone for the purpose of storage is not really going to happen. What would be maybe your message towards the TSO, DSOs, and the legislators behind that? It seems like they're pretty lazy, if I can say that, because they seems like to be working within the framework of, the world has been always with the big gas and coal and other type of power plants. And this renewable stuff, let's not deal with it. That's the way it seems like. What's your message to them?
I would say that it really depends on the country, you know, because in some countries, at least at the transmission level, presently, it's really very open. I mean, at least for aggregation. And but when you want to propose something on the transmission level, you really need aggregation. That's one thing.
Yep.
And so in some countries, really, things are rather very good. In other countries, it's not the case. So that's why I would recommend for the regulators or for the TSOs also, because sometimes the barriers come from the TSOs to look at the possibilities or the flexibility that can be provided by distributed resources. At the DSO level, I think it's a start now. So they are starting to test or to different types of, let's say, procurement mechanism. Things are evolving, but of course, indeed, they should continue this exercise and look at best practices from different countries and things like that. So I think
clear.
that's what I can.
Indeed. Thank you very much. Thank you once again for a very nice presentation. Very clear. My experience with DSOs in Netherlands at the moment is that their approach to deal with too much flexibility in the grid, they just ban PV and wind, and they are fine. So they pretend the problem is not there because they just don't allow the renewables to be put in their system, which is easy, but obviously does not really address the main challenge we have.
As I said, you know, it's really the situation is very different from one country to the other.
Yeah, indeed. Again, thank you. The next presentation, the last presentation of the day, but certainly not the least, will be given by Andrej Mišek from the RHC platform. He will present us his view and their view on the research and innovation priorities of the renewable heating and cooling and the implementation challenges that are there. Andrej works at the Association of European Renewable Energy Research Centers, and he's responsible there for the coordination of the renewable heating and cooling ETIP's secretariat and oversees the preparation process of the recently published RHC documentation. Andrej, the floor is yours.
Thank you very much, Paul, for this very nice introduction. What I will be trying to present in the next 10 to 15 minutes is the work of RHC-ETIP, especially on the research and innovation priorities for renewable heating and cooling, and also our monitoring work of their implementation. So the European Technology and Innovation Platform on Renewable Heating and Cooling in a nutshell, it was founded in 2008 and represents the entire sector of renewable heating and cooling. So this includes 5 technologies, well, more technologies, but 5 major stakeholder groups: solar, thermal, biomass, geothermal, heat pumps, district heating and cooling, and thermal storage. A few years ago, after discussion with the European Commission, it was decided to structure the work of RHC-ETIP also according to horizontal working groups, which would address the end use of these different technologies. So after this decision, 4 horizontal working groups were established, and these are focusing on 100% renewable energy in cities, districts, buildings, and industries. And this is basically the structure of RHC-ETIP. These technology panels, different technology panels are basically pools of experts, and these then meet to discuss any relevant issues either in these technology panels or horizontal working groups. In the past 3 years, the RHC-ETIP has produced 3 strategic documents. In 2019, it was the 2050 vision for renewable heating and cooling. in 2020. It was the Strategic Research and Innovation Agenda. And last year we prepared more like a report for the Commission to showcase how the priorities identified in the STRIA are being implemented by RHC stakeholders. So very briefly on RHC TIP STRIA, the main objective of this document is to underline the importance of heating and cooling sector for the successful transformation of our energy system towards climate neutrality. It is based on the 2050 vision for 100% renewable heating and cooling, which was prepared in 2019, as I mentioned. And it presents the benefits of replacing non-renewable energy source fuels by climate neutral RHC technologies in heating and cooling sector. It also identifies the technological gaps and describes the R&I priorities needed to unlock the RHC potential. And these identified priorities should serve as input for future Horizon Europe's goals for renewable heating and cooling technologies. And of course, the overall objective of RHC ETIP and this document is to pave the way to stimulate the strong uptake of renewable heating and cooling technologies. The document is structured according to transversal topics, which are applicable to all 4 horizontal working groups, so buildings, districts, cities, and industries. And then there are 4 chapters on focusing on these horizontal and these areas individually. Of course, we wanted to base the document and the priorities on some specific and solid numbers, because Commission, of course, doesn't want to hear only about what we want to do, but they are of course interested in seeing specific numbers. So we created some graphs. For example, here on this slide, you can see the graph of final energy consumption in the EU27 by energy use and origin. And on the first bar, you have the 3 main areas of energy consumption, so heating, electricity, transport. And this was in 2007. So as you can see, we didn't include numbers for 2020 when the document was created, but we had numbers for 2018. And as you can see in this light yellow color, there is a big part of heating is still supplied by non-renewable energy heat. But positively, there is already some part of this heating supplied by renewable heating and cooling technologies. So the European Commission's plan under the 32% overall target for RES is to reach by 2030 certain amount of renewable energy and heating and cooling, and then this is based on annual average increase of about 2.3%. So if member states follow this annual average increase of 2.3%, by 2040, 50% of heating should be supplied by renewable heating and cooling technologies. Combined with the consumption reduction due to efficiency measures in the building sector. Of course, you can see that the overall need for energy consumption is lower considerably compared to now. To here, the tall bar in 2018. However, we wanted to be ambitious, and so RHC ETIP experts actually foresee that 100% can be supplied by renewable heating and cooling. And it is achievable if the implementation of new innovative RHC technologies is accelerated. So this is a 2040 scenario, that the last bar, where 100% would be supplied by renewable heating and cooling. On the next slide, these bars are then shown as a final heat supply by source, and again showcasing the 2040 scenarios. As I mentioned previously, in 2040, 50%, European Commission still foresees 50% of heating and cooling to be supplied by non-renewable energy. heating and cooling, but we want to be ambitious, and we believe that by 2040, 100% can be supplied by renewable heating and cooling technologies. And the technology distribution in renewable heating and cooling is much more diverse than expected in the clean energy trend, or follow-up trends, as we called it. So much higher contribution from solar thermal, geothermal, heat pumps, e-gases, and hydrogen is expected by 2040. And yes, so maybe interesting to highlight is the EU Green Taxonomy. So for sustainable activities or actions, the inclusion of natural gas naturally is seen by RTE as a kind of distraction from investment in truly renewable heating and cooling technologies. So this is one of the policy issues that we are dealing with at RTE level. And the SRIA document proposes to unlock the potential of renewable heating and cooling, and it is definitely key at this time of increasing energy prices and energy security, because understandably REC technologies could significantly lower or minimize the dependence, energy dependence on other countries and oil and gas imports to the EU. To briefly showcase the type of priorities that were identified in the SRIA, specifically for technologies of heating and cooling, storage and distribution, which is relevant to the SCORES project. One of the priorities was to develop and demonstrate energy storage and distribution solutions for heating, cooling, and district hot water production integrated with renewable energy sources, both in active and passive ways. So very much in line with the objectives of SCORES project. There was also the section on priorities for 100% REC in buildings. The priorities identified are quite generic, because this was the wish of the European Commission to keep it this way. So renewable energy, heating and cooling technologies and systems for cost-effective retrofitting of old buildings and historical and special buildings were identified as a priority. Renewable energy sources, fuels, technologies and systems for new buildings and their integration and external connectivity. Combined heat and power technologies and systems and their integration in old, historical and future buildings and their external connectivity was another priority identified. And then energy systems, education, training, and certification for different building categories as, let's say, the last priority identified. So I mentioned these key takeaway messages from the document already several times. So the main message of the document was that 100% renewable heating and cooling in buildings, districts, cities, and industrial processes in Europe is achievable even by 2040. And we can achieve this actually already with with currently available thermal renewable heating and cooling technologies. But raising the public-private expenditure for REC research is crucial, nevertheless. And this should be to the average annual level close to 2 billion in order to unlock the full potential of REC. The strategic document that was prepared by REC-TIP is in short deployment and implementation report. So we try to survey stakeholders to get insight into REC community's research, development and innovation activities and trends, and to see how the previously identified priorities from SRIA are aligned with the actual RD&I activities of stakeholders. We also identified some gaps between the world of theory of our SRIA and the actual real world of implementation, and we acknowledged these and reviewed these. The document identified some trends, which sound quite obvious, of course, to people active in the heating and cooling sectors. So there is a trend towards cross-cutting technologies, sector coupling, integrated or hybrid systems, which would increase optimization and efficiency. Also, greater inclusion of and cooperation with other renewable technologies, particularly hydrogen-based renewable energy systems, and also district heating and district cooling, thermal energy storage, of course. REC sectors are looking to increase the digitalization also, and investing a greater amount of revenue into RD&I activities in RHC. This was, of course, quite positive trends that we identified. Regarding the implementation of the priority identified in STRIA on technologies of heating, cold storage, and distribution, this was probably the priority with the highest indicated relevancy to respondents. So 83% of respondents indicated that this priority is highly relevant, and activities being realized are aligned with the desired results indicated in the STRIA document. So achieving greater use of rest thanks to the use of thermal storage, adaptable storage cycles, residual heating integration in CHP systems, cost reduction, etc., etc. Main takeaway messages from this document, again, repeating also a bit the main messages from the STRIA, that the major contribution from all renewable heating and cooling technologies will be needed for Europe to achieve climate neutrality by 2050 or 2040, if we want to be more ambitious, of course. But this requires adequate support and funding for demonstration projects and to increase the market upscale solutions. Greater technical assistance for the preparation of investment projects, and also more awareness from investors and decision makers about existing applications and installations. Also strong cooperative measures with research centers and other industry organizations, and widespread market support actions across the EU are a few of the required actions that should be implemented still to support renewable heating and cooling development in the EU. So this is basically the two documents in a nutshell. If you have any questions or you are interested in the work of RHC, feel free to visit rhcplatform.org website or become a member. If you are a stakeholder working in one of the technology sectors relevant to renewable heating and cooling. So yes, thank you very much for the attention. And if there are any questions, I'm happy to answer those.
Thank you very much, Andrei, for a very nice and clear presentation. I don't see questions in the chat and I don't see hands raised, but I do have a question. You've been working and this is a work in progress, right? It's constantly reviewing changes and seeing how things develop. The last few weeks have brought us to the brink of huge change that seems to be happening. You've presented to us a vision of 2030 with an energy efficiency jump to let's say the whole bar got a lot smaller. When I look at the previous past, we all talk about it for 20 years, nothing happened. The first since 2007, 2020, nothing happened. Before 1 month ago, 2 months ago, I would say, what's happening really? Are we really truly changing something? What is your view on the situation right now?
That's of course very relevant questions for heating and cooling sector in Europe. Until recently, and we have seen this for past years, even decades, is that heating and cooling, even though it's very crucial for all citizens of the European Union, it has been neglected, and the true and existing solutions were also overlooked. And the policymakers or decision makers have been looking for some miracle solution to decarbonize the heating and cooling, even though the solutions are already here and existing. So definitely it's unfortunate that something so radical had to happen, such as war in our neighborhood, that suddenly we have a feeling that things might be turning for better for renewable heating and cooling sectors in Europe, because again, decision makers need to lower the energy dependence. So yes, the things are looking a bit better than a few months ago, perhaps. More money are going to be funded to move towards energy efficiency activities and decarbonization of heating and cooling. So this is of course positive, but it's against a backdrop of very negative things happening. So that's probably a pity that this had to happen for decision makers to see the way, I would say.
Yeah, thank you very much indeed. And I think the positive aspect of the message that even though things don't go in some places well, but the impact here on what we try to reach for the decades is now has a light at the end of the tunnel. That is the good news, the good part of this whole story. Thank you very much for your presentation and for your answer. And I think this was also the last presentation that we have had planned for today's policy workshop. Linked to the SCORES project. I would like to thank everyone for their excellent presentations and contributions for this workshop. Maybe last question to Gilles. Would you like as organizer to maybe say a last few words at the end?
Yes, yes. So we reached the end of this policy workshop. Indeed, thanks to all speakers and attendees also for participating to this event. We see that we still have some work ahead of us, I would say, related to the implementation of adequate supporting scheme or policy. We had through this presentation have a rough overview of some of the measures that could be taken and barriers also related to that. So I think the story is not finished, and we need to work more on that policy, but also on technology. Still, there is also a barrier on technology, even so. Lots of technology are ready, but in order to make the system more able to deal with this renewable energy surplus locally, we need to ensure proper communication between all these components. And with that, I want also to say that this policy workshop was recorded and will be published later on the SCORES YouTube channel. So I invite you also to share this link further on. And with that, I want to thank you all again and wish you a nice end of the day.
Thank you. Have a good day,
Thank you.
everyone.
Good day.
Very much.
Bye-bye.
Bye-bye.
Bye.
Bye bye.
Bye.
Thank you. Bye bye.